Lesson 5 is about analyzing business requirements for a cloud solution. So, in this module, you will complete the following exercise: cloud requirement analysis factors, differences in cloud environments, and testing techniques in the cloud. After completing this module, we should be able to define and describe different factors that impact requirement analysis for business needs, calculate composite SLAs, define and describe different cloud environment and their uses, investigate the AWS platform to explore development environment options, and define and describe different testing techniques in a cloud environment, and also configure the Serpico web application for penetration testing in a private cloud environment. Alright, so in exercise 1, this will be cloud requirement analysis factors. So when building a cloud infrastructure, business considerations can take a few forms, such as budgetary requirements, software licensing and agreements, and hardware purchasing and logistics when considering on-premises infrastructure. So picture a scenario in which a private cloud infrastructure struggles to serve customers due to increased demand on the servers, resulting in a poor user experience. In this case, it could be a business requirement to switch this infrastructure to a public subscription because servers hosted by a cloud service provider or CSP would be under a service level agreement or an SLA that dictates a certain percentage of uptime, as well as the current infrastructure not meeting user needs. Both are considerations that should be considered before an infrastructure is built. So when it comes to cloud requirement analysis factors, one that we should consider is software and hardware. So when building an infrastructure, it is important to consider that what software will be required for a user perspective and what software is required for the infrastructure to run correctly. This could be anything specific coding software such as Microsoft Visual Studio for database environments, which is free but still requires agreement to a license with Microsoft, or a valid license for an OS such as Windows Server 2019, which has an associated cost. Now, this same principle applies to hardware. Specific devices may need to be purchased to ensure that everything functions in an on-premises infrastructure. Another one would be networking. So it's important to consider what kind of networking infrastructure will be required. This could be hardware related for on-premises, such as purchasing, routing, or switching hardware, or virtually in a public cloud environment. You should consider the following questions when investigating a potential network. So sizing, what bandwidth is required for the needs of the business, and what kind of response times will users expect? How much data will be transferred? Now, when it comes to subnetting, what kind of subnetting is required? Which solution will provide the best speed and performance? And in routing, are there security or data transmission considerations that should be investigated? Integration. So also important to consider when building an infrastructure is that data, applications, systems, databases, and environments need to be integrated to allow for easy exchanges of information in real time. This is something that can be done internally via proper planning and consideration when building different devices to work together. Although you could also investigate an integration cloud service broker or ICSB, which is a platform that acts as a data brokerage and can assist in the management of integration. However, it is important to consider that this also may have associated costs. Another factor would be compliance and security. When building an infrastructure for a business that reports to a regulatory body, it is imperative to ensure that it meets the requirements set by the regulations that need to be followed. For example, personally identifiable information or PII will require user to user data to be kept secure. So the security of a database that stores this information will have to be configured to meet these requirements. However, it is imperative that your infrastructure is not susceptible to known security threats, and these should also be considered. Just as with the ICSBs for integration, you may consider implementing a cloud access security broker. And the last one would be service level agreements. So a service level agreement, or SLA, describes the commitment between a service provider and its customer for some type and amount of service. So an SLA contains all terms of service rolled into one document, which serves as the rulebook and legal contract between the provider and the customer. So typically, SLAs do the following. They establish the provider's commitments for individual products and services. They also establish the performance targets for those products and services. And they specify what type of remediation is available if a product or service fails to achieve the performance target. So most products and services performance targets are described in terms of uptime and connectivity or availability guarantees. So taking Microsoft Azure as an example, remediation when performance fails is given in the form of service credits to the account or subscription. Because service credits are a type of currency for Azure products and services, Microsoft's SLAs are considered to be financially backed, although they do not provide SLAs for products and services that fall under the free or shared tiers, such as the Azure Advisor. Alright, so for our task 1, calculating a composite SLA. Now let's open the Microsoft Edge. So in Microsoft Edge, the Azure portal will open automatically, and once this process has been completed, let's open a new tab and go to this website. Now on the Azure Service Level Agreement website, scroll to the networking and select Application Gateway. Note that at the top of this page, Microsoft have noted the SLA guarantee as 99.95%. On the Microsoft Edge browser, click the back arrow located in the top left and return to the main page. Now back on the main page, let's go to Compute and then Virtual Machines. Now for this example, let's assume we will be using a virtual machine with 2 instances deployed across different availability zones. At the top of the page, you will note that the Microsoft have given an SLA guarantee of 99.99%. So availability zones are different locations that houses the physical aspect of a resource. For example, if you were to create a virtual machine based in the UK South zone, it will create their resource using hardware based in that area. So each availability zones is formed of one or more data centers and are maintained by Microsoft. Once again, let's head back to the main page. Now let's go to the navigation table and find Web, and then App. App Service. Again, Microsoft have a set of SLA for this service, which is 99.95%. Let's head to the main page table and then go to storage and storage counts. For our example, let's look at the first service. The availability time for this is 99.99%. Now in exercise 2, this will be on differences in cloud environments. So different infrastructures can be used for different purposes, both inside and outside cloud environments. Dependent on business needs, you may need to investigate developing an infrastructure that is used as a testing bed before deployments are implemented directly to end users. So typically, such environments form part of a wider development operations or DevOps strategy and can be built in both private and public clouds. So when it comes to different cloud environments, a production, also known as live environment, refers to the operational environment for end users. So in most cases, anything pushed to a production environment has passed many different development phases and has been greenlit to be ready for user consumption. Now, a development environment, typically shortened to dev, refers to an infrastructure built for development teams to edit, debug, and build applications or code in a safe sandbox setting. So similar to development, staging environments provide a safe space to allow change testing before pushing updates to a live environment. So in a real world scenario, updates may pass through development stages but not to be ready to be immediately deployed to live servers. So this is when a staging environment may be used. Now in quality assurance, QA in a DevOps setting refers to a specialized team stress testing new deployments to catch any issues before releasing them to the production. Now, blue-green is an environment that refers to two near identical production environments where only one is live or available to serve traffic, whereas the other is not. In real-world scenarios, these types of environments are used to gradually roll out updates, where one is used to serve all traffic, which then swaps back and forth to manage different incremental updates, reducing service downtime and overall risk. Lastly, in disaster recovery, now in terms of infrastructure, DR environments are constantly updated copies of other environments that allow failover should one of the environments be brought down for any reason. These exist to prevent server downtime and are known as hot spares. Now for the first task, we will be investigate development environments in AWS. So AWS has different DevOps tools available that can be implemented in different environments, set out by business requirements, including tools for deployment, staging, blue-green, and QA environments. So in this task, we will investigate different deployment tools available in AWS, such as AWS Code Build or Code Deploy. So let's open our Microsoft Edge again. So when opening the Microsoft Edge browser, it will automatically reflect the AWS portal. The login credentials has already been provided. Let's just click sign in. Once logged in, click Services at the top of the left-hand corner of the page. The service menu will appear, and just navigate down to the menu and click on Developer Tools. Next, click Code Build in the flyout menu. Code Build. So on the Build Projects page, you will be provided with a notice that you do not have permission to access this page. So in a real-world scenario, this will also depend on the type of permissions assigned in this infrastructure. For the purpose of the demonstration, we will investigate the different options available here. So from the menu on the left-hand side of the window, click Getting Started. Now scroll down to the Benefits and Features section and take a look of what sort of environment tools this tool offers. So we have fully managed build service, elastic scaling, pay-as-you-go, extensible. So AWS Code Build allows a safe sandbox environment for testing purposes, meaning that this acts as a great DevOps tool. This can be utilized in many different testing environments, such as development, staging, and blue-green. Although the exact implementation of this tool would depend on the specifications and structure of the infrastructure. Alright, so now on the menu on the left-hand side, expand Deploy, and click Getting Started. Now this will bring us to the AWS Code Deploy Getting Started page. Now once again, scroll down to the Benefits and Features section to review the application of this tool to DevOps environment. So some of the benefits and features include automated deployments. We have minimized downtime, centralized control, and easy to adopt. So overall, this tool allows easy deployment of code, allowing for safe sandbox testing. Just as with Code Build, this allows developers to deploy code to development and QA testing environments, and then also to staging and production once the deployment has passed the testing phase. Now let's proceed to task number 2, and this will be investigate disaster recovery and in AWS. So alongside offering tools for different development environments, AWS also offers tools to assist administrators with disaster recovery. Using tools such as Elastic Disaster Recovery or AWS DRS, you can set servers to have DR enabled on a subscription basis, as well as easily manage failovers and log all reversions. So in this task, we will investigate AWS DRS. Now let's click on Services, and from the flyout menu, click on AWS Elastic Disaster Recovery. Where is it? AWS. AWS Elastic Disaster Recovery. I can't find it. Now let's click on this menu. And click on Source Servers. Now this will bring you to the page of source servers. In a real-world scenario, provided that you had proper permissions, you could set a source server, or the server that currently stores data and acts as the source, to have disaster recovery enabled. This would then initiate secure data replication through to another server managed by cloud service provider. Now let's click on Recovery Instances. And just as with other tools in the lab environment, you will not be able to make any changes as you do not have the correct permissions. Now the recovery page will show you different instances when a source server has been replicated. Now let's check on recovery job history. Now this page will provide you with a list of each and every data recovery job that has been initiated by either you or an administrator. Now this allows you to keep track of when data has been retrieved from a failover state. Now let's click on Settings. Now the settings page will allow you or an administrator to configure different replication settings from the source servers. Finally, let's click on Documentation. Now this will open a new tab titled What is Elastic Disaster Recovery? Now this document will provide you with an overview of the disaster recovery process and how to safely operate the tool in a real-world environment. Let's close all windows and proceed to the next exercise. Now in our third exercise, this will be testing techniques in the cloud. When it comes to cloud computing, there are many different types of infrastructure configurations. And as such, it is key to ensure that different testing techniques are used for different applications, depending on the environment that needs to be performed. So different testing methods can ensure that an infrastructure has sound security, performance, functionality, and user friendliness. So some of the cloud testing techniques would be vulnerability and penetration testing. So vulnerability testing involves identifying existing weaknesses that exist in an environment. Typically in a real-world scenario, this is an ongoing process performed in many different types of environments and is key to ensuring that there are no security vulnerabilities that could result in an attack by a malicious party. Similar to vulnerability testing, penetration testing involves a specific person employed by an organization, known as a pen tester, exploiting weaknesses that currently exist in an infrastructure. So this type of testing is also done for many different types of infrastructure, and aims to find vulnerabilities that have not yet been detected, which is the distinction between vulnerability and penetration testing. Another technique would be performance testing. So performance testing aims to test the response times and stability of an infrastructure, and although it may be done in internal environments, it is key to perform in a live production environments. So this type of testing aims to discover if there are any issues with performance for end users. Another one would be regression testing. So regression testing is a process that aims to prove infrastructure functionality after updates. So in real-world scenarios, this type of testing is used to ensure that when a new piece of hardware or code is added to an infrastructure, it doesn't adversely affect more legacy hardware or code that may already exist. Functional testing. This aims to verify an infrastructure against set requirements. This type of testing is important for internal testing environments such as development and staging, and involves testing an infrastructure to ensure that it meets the requirements of the business. And lastly, usability testing. This measures the user friendliness of an infrastructure. More important for production environments, this type of testing ensures that an infrastructure is usable for a wider audience outside of development teams. So picture a scenario wherein you are developing a web application. Usability testing would be key to ensure that the application is usable. And this goes to for people with different types of devices, from smartphones, tablets, laptops, or desktops. Now, in this exercise, we'll investigate penetration testing techniques in a private cloud environment. So for our first task, it's to explore private cloud penetration testing. So Paku is mainly designed for security professionals who want to test Amazon Web Services security. So Paku runs with the modular architecture that can be used in penetration testing. It contains several tools that can be used for testing security of an AWS environment. So one of the features of Paku is that it is an open source application that is freely available on GitHub and can work with both macOS and Linux environments. Paku also covers the entire penetration testing lifecycle, which can include the following: reconnaissance, persistence, privilege escalation, enumeration, data exfiltration, log manipulation, and credentials compromise. Now, Paku contains various models that can be used in various stages of security testing. Some key modules are the confirm permissions. These are lists the permissions for the account being used. Priv-SC scan can utilize 20 or more different privilege escalation methods. CloudTrail CSV injection can inject malicious formulas in the CSV files that are being exported from CloudTrail. We also have disrupt monitoring, which can disrupt the monitoring capability within the AWS environment. And backdoor users can be used to establish backdoor account access. Sysman EC2 RCE can break the AWS Simple Systems Manager to gain access to the root account. And lastly, backdoor EC2 sec groups can be used to add backdoor rules in EC2 security groups. So in this task, we'll learn to explore Paku using Kali Linux as an example of a penetration testing tool used in cloud environments. Now from the desktop, click the terminal icon. Terminal. Let's connect to this desktop first. Now clone Paku from GitHub by typing the following command. Can you copy this? Guess not. hit enter. Once the cloning process has been completed, navigate to the Paku directory by typing cd paku. Press enter. After you navigated to the directory, execute the install sh script for Paku by typing the following command. Press enter. Alright, so notice that the installation process for Paku starts. Let's wait for the installation to complete. Once done, let's hit clear. After the installation has been complete, start Paku by typing the following command. So python 3 i.py. Paku starts with a new session, which will you need to name this plab. Now list all modules in Paku by typing list. So there are different categories with their in this module. Now you can find the information about the active access keys. So notice that the prompt already states that no keys are set. However, you can still run the following commands. So who I. The response you receive is false. This is because no active keys are set, but in a real-world environment, it is likely that active keys will be enabled, and therefore you would proceed to use the tool to perform penetration testing. So let's view various regions in AWS environment by typing regions. Now we have all the regions listed here. So an unfigured environment for this tool has been shown in the lab environment as an example, and therefore does not perform a full penetration test. But in a real-world scenario, however, this tool would be configured to run alongside an active subscription, and therefore much more information can be gathered. And that's it for that task. And we have finished. We have completed the analyzing business requirements for cloud solution. Hit done.